Jai Hind everyone. From the last video, we already understand about the spherical mirrors. Since from the understanding we come to know that we have two kinds of spherical mirrors. The first is concave mirror and the second is convex mirror. Now we will talk about the ray diagrams. That means the image formation by the two kinds of spherical mirrors. So let us first understand the basic component, or you can say the basic keynotes of the spherical mirrors. We start from the keynote of spherical mirrors. The first point is center of curvature. Yes, where you have seen in the figure that a hollow sphere we have taken in 2D, that is called the center of this curvature of the center of this hollow sphere. Next, the radius of curvature. Actually, the distance between the C, the center of curvature, and the pole, or you can say the edge of the mirror, is known as the radius curvature. Will be equal in all directions. Pole. The mirror you have taken out from the hollow sphere, the midpoint or the middle point is known as the pole. In the next slide, we are going to see the next few points. The principal axis. Yes, this is a very special term because this is the line which will be joining the pole, center curvature C and the infinity. Yes, this is a straight line passing through it. All these points. Secondary is the same but just in opposite direction. Yes. Aperture of a mirror. Aperture is actually the limiting area of the mirror you have taken out from the spherical surface or hollow sphere. Yes. So the limiting area of the mirror is called aperture of the mirror. Generally it is the radius of generally it is the diameter of the sphere. Okay, now we will see the all cases of concave mirror. So it is known as also the image formation by the concave mirror. The first case, when the object is at distance. Distant means is infinity. Object when is at infinity, we say it is a very negligible. We cannot find out actually the size of the object. That's why it's taken as pointwise. The light ray coming from them, it became parallel to the principal axis, and after incident on the spherical mirror, just like concave mirror, it will bounce back and meet at a fixed point is called F. That's why we can conclude here the image is formed at focus, the point A, the point B, it is real and inverted, and it will be highly diminished. Second case. Second case is quite easy. When the object is between infinity and center of curvature. Now the object is moving toward the mirror. That's why here we can take that AB, the size of the object standing actually in front of the C, in between the infinity and C. So the two light ray will be taken out. One will be parallel, which is the light ray coming from the object or source, and one light ray, I can show you the server, see the cursor. This slant ray, or you can say the inclined ray, actually coming from the nearest point of the object, which is called C. The cross section point is known as our image. Since it is vertically downward, so we can say it is an inverted image. So the image formed like this case between F and C. Here you can see the B size of the object is less than, because last was very pointwise. Now it will be the diminished. Since it is real, because the object is in front of the mirror, we can see easily. That's why. And now it is inverted vertically downward. Third case. When object is at C. C means the center of curvature. Now we are using symbolic letters here. So when the object is at C, C is the center of curvature. From here again we take two rays. One will be parallel, one will be inclined. The first ray, which is parallel, will come through the focus because it will bounce back, and second ray we can take because the nearest point of now of the object is become F. So inclined will be go from F, and again it will bounce back like parallel. Yes, so the meet point again they are fixed at the just downward side of the object. That's why at the same point where the object is situated, the image is obtained. That's why we can say it will be the same size, but again it is real and inverted and formed at C. Move forward to the next case, the 4. When the object is between C and F, C means center of curvature, F means focus. Now remember the last case actually. The last case we already have seen that it was the equal size because it was at the C, center of curvature. Now just it is a common sense when you are going towards the mirror, since the last case was the equal, so next will be always enlarged. Yes, because when you are come in front of anyone, you become enlarged because your sight, the angle of vision will increase. Yes, so now here again we take two rays. Actually the rays are actually going from the A. You can see the mouse cursor. You see that here the first light ray goes to the mirror and get back again to the same direction. So now the cross section, they meet at the point where in between the C and the infinity, or you can say distant. Again it is already you can say vertically downward, so it is inverted. Since it is in front of the mirror, it will be real, and image is beyond C. Yeah. Next case, the fifth. The fifth case, when is object at F. Now move towards the mirror little bit more. So now the object is at F. Again the same case we will take. One will be parallel coming from the infinity or source, and it will go through the focus. And second case, the inclined ray, again we will take the same, but now here you can see the spacing between them is equal. Yeah, the spacing between them is equal now. That's why we can say that this will be goes to infinity and it will be highly enlarged. Now this is the last case, when the object is between F and P. F means focus, P means pole. Pole is at the mirror, you can see the midpoint of the mirror, so we cannot go beyond of it. So this was the last case. Image obviously formed behind the mirror. Why? Because here you can see clearly the A point. The AB is our object. The light ray actually goes backward side because from now it is not parallel. You can say CA and NP. Yes, the CA and NP, the rays are not parallel actually. They are diverging each other. And you know that for the diverging ray we cannot form any kind of image. That's why they are supposed to go backside. Since we are supposing only, they are not actually going because it is actually a opaque material. The mirror is not a translucent. That's why we are just only can suppose to that it is going backward. That's why the light rays are actually shown by the dotted line. Now the AB is our imaginary image. Since it is vertically upward, we can say it is erect. The image formed by this kind of situation will be enlarged, virtual and erect and behind the mirror. Now we can see the application of concave mirror. Since it has a parallel kind of properties and the diverge kind of properties, that's why we can use it as a reflector in a headlight, torch, etc. and such also. Shaving mirror we can use. Solar cookers, actually the parallel beam of light easily we can fall on a mirror, so it will focus, result the temperature will increase. ENT specialist use this kind of spherical mirror. ENT stand for ear, nose and teeth. These are very small part of our human body. That's why so specialists use the spherical mirror to see the larger view of this kind of parts of our human body. Thank you. Now the next topic is the image formation by the convex mirror. The first case, when the object is at infinity. Yes, when the object is at infinity, we consider the object is as pointwise. So the light rays coming from the infinity become parallel to the principal axis. So after incident on the polished surface of convex mirror, since it is bulged out, so it's supposed to, yes, it is converging. but since it is an opaque thing, the light will bounce back, and when it bounces back you can see the mouse cursor here, they are diverging, and you know that by the diverging light of rays we cannot form any image. That's why they are supposed to meet backside of the mirror. Since backside of the mirror they are virtual, that's why it is considered as a virtual image, and this focus is our image. Yes, so the image formed at focus behind the mirror, and it is virtual. Since it is virtual, so it will be the erect always and diminished because it is pointwise. Next point, the second case. Since the image formed by the convex mirror is object as a appear virtual image, that's why it have only two cases. When object is in between infinity and the pole, it is the second case. So anywhere we can put in front of the convex mirror. So here again we take the same thing. The object, the first light ray goes from the focus, and second is from the parallel rays of light, and the one is inclined. So here they will diverge actually, and again the diverged light ray, when they meet behind the mirror, here the red point behind the mirror, when it meet they form an image, and this image again will be virtual, but it is again you see clearly that is diminished. That's why the image formed between pole and focus, as you see here in the figure, yeah, this actually the center of curvature, because now it is the curve is like that in this kind of side, right side. Okay, that's why the center curvature is taken in this side. So image formed between pole and focus, it will always erect because it's a virtual image, and again it got diminished. So it have only two cases. In both cases we see one common thing, that image is always diminished. Now the application of convex mirror. Here we see already that the application can be used to diminish the objects as appear as an image. So drivers can use it as a rear view image, so that backside what they are coming from the behind a truck or any other vehicle, so long view they can see. That's why the driver use that kind of mirror, the convex mirror. Yes, in the street light also we can use, and the last, the big shopping stores as a vigilant mirror we can see, so that the shopkeeper can see the wider area in this shop. Thank you. We start from the keynote of spherical mirrors.